So the first benefit of going containers first, what happens when you go containers first and you see what you're going to run is that you will optimize what is running. So left to right, what we have here is memory footprint of a Quarkus plus native, meaning that this code was developed specifically to run as Quarkus. Then we have Quarkus plus JVM. This meaning is that we have code that was running as a Spring Boot or any other framework and has been transformed to run as Quarkus, either by a pre-compiler or by your modifications, but this is still a significant amount of code. And then the traditional cloud native stack, like let's imagine a Spring Boot. For startup time, we see that the Quarkus plus native is 16 milliseconds. This is very, very fast. Like we have done a lot of development with Node.js to create fast functions before Quarkus was this mature. And these times are awesome by any standard. When we go to Quarkus plus the JVM, we are still seeing below second start time, which is pretty good there. And when we compare it, when we compare it with the traditional cloud native, that is 4.3 seconds. Now, this allows us to have higher density of VMs or of containers when we have that running in a container orchestrated platform. So if before I had 20 Spring Boots in one node, now I can have 200 Quarkus running on the same on the same node for the same amount of resources. Again, we are still reducing that code from monolith to microservices and from microservices now into functions. Let's move to the next slide, please. How does this translate to developer joy? This is something that it is a little bit arguable. When you are coding and you are changing something, if you're changing something in a Spring has a refresh, automatically refresh in the background, running in the background. So as you change, you will see the changes running in your debugging environment. It is good until you try something that is a lot better. And I did a transition from Java to Node.js and to Python. And then you realize how fast something can realize of a change. But when you're coding in Node.js, you change something and it's automatically, instantaneously. It takes less time for the code to be refreshed than for me to change the window. When I change the window, the code is there already and is running. And the same thing happens with Quarkus. It allows you to do like a continuous debug of the code. Your code is always running. And that is, for some developers, awesome. For some others that they don't like to use that, not a huge benefit.
Hey, Jose, I have an example of where that kind of fits in here where a customer, that was moving to OpenShift. So, many of the people that are moving to OpenShift, they're looking to solve some problems like onboarding more easily for, new technologies, lowering the administrative burden of deploying distributed interrelated services, also stuff like limiting the work needed by an application team to deploy a component and then transitioning to a hybrid cloud deployment model. This is a lot of, some of the big high level reasons people move over to OpenShift. And so there's a number of ways to tackle these. And so this particular organization, what they did is they first tried several different ways on their deployment model to solve it through some existing tools, but they decided to write a solution in Java. And so mainly this was, they figured out to get better performance, use higher level language, get better support for the unit and integration testing, as well improve productivity with quality development tools. So this was going really, really well. And they ran it as a task in Tecton pipelines. So this was all good until they started to have to deploy in multi-tenants. So they sized this stuff as like 200 millicores and 280 megabytes of RAM. So some of the applications started to need 30 tenants deployed in parallel, which meant 30 pods, 6 cores, and 8 gigabytes of RAM. So it was starting to become pretty hefty on these deployments. And so they were concerned as this started to grow that that was going to be a bigger problem. So here's an example of how this helps, like developers and deployments. They decided to leverage Quarkus to improve the performance because they wanted to deploy it in Grail VM executable. After testing several configurations, they were able to get this down to 50 millicores and 50 megabytes to solve their performance. And the interesting thing was they realized they could actually tweak the CPU knobs and the memory knobs to kind of fit their execution duration use case. So if they wanted to change that time, they could increase resources or lower resources. So it was like a really awesome solution for them where they took a use case in Java and then just moved it into Quarkus, and it really, solved the problem. So there's an example of a real world story on that. So back to you.
So the last benefit, again, for somebody that is like native Spring developer, they will not see this as a benefit, but for many other people, it will be a benefit. That it's the unification of imperative and reactive declarations. So now you're going to see more specifically what are you going to get. They are going to be using the JEE standard for injection, which again, this is a matter of opinion, and in my opinion, this is the right way to do it. So let's go to the next slide, please. As I was saying, Quarkus is being adopted massively by the industry, and more vendors, more and more companies are creating their own libraries and their own like add-ons for Quarkus. From Eclipse to, well, I think we have a slide later for the IDEs, but from all of these vendors, you will see that they have specific components that you can use when you are developing. When you are developing with Quarkus, you go to quarkus.io and you say, all right, I want this, and that. And that creates you the skeleton where you can just enter your code and you don't have to worry about anything else. So from a development perspective, from a developer experience, it is a great tool to have. Again, a tool to have, not to replace all your other tools. There are going to be things that you're going to want to have that thick JVM because you're using that JVM for its purpose. In some other cases where you are not really using the JVM for what it can do, but only to host a simple function, that's where you can have this reduction. And it's not that you can only run Java, you can run Camel, you can run, you can have connectors to AMQ, you have connectors to Kafka, you have connectors to a lot of different things. Let's move to the next slide, please. So what's this SUPERSONIC and SUBATOMIC? If we go to the next slide, these are the times that we were seeing before. If we do only a REST function, so we just expose a function that does some calculation and return. That's what we have on the part on the top, and on the part on the bottom, we have a REST and a CRUD, like access to a database where we do a create or read, update, and delete of an entity. You can see the times. The times with a full Quarkus plus JVM is still 5 times faster than a traditional Java cloud native stack. If we go to the Graal VM, that would be a little bit heavier on the transformation because you will have to transform your code to run. That is still like, it would be 42 milliseconds. Like, this is a phenomenal time. Let's go to the next one, please. If we look at the footprint of that, of a Quarkus, we are talking about 12 megabytes. This is what Todd was alluding earlier. On a Quarkus plus JVM, this is 73 versus 140 almost. So it's half of the size, and it is very, very thin when we do Quarkus plus native. Let's go to the next slide, please. Yeah, George, I see your question. We are going to see that in a minute. It's a little bit further in the deck. Let's get to the next slide, please. So when we are saying how will a customer gain all these benefits, so at the end, when you have Kubernetes cluster and you have all your nodes, Quarkus will run on inside of a node as a container, and the density that you can get is a lot higher than with Java, just because the size of it. The size of a Java container is just twice the size of a Quarkus, be it by memory, by CPU, by any standard way, however you want to measure it. So as long as you can move the code, it is a good savings. It is a good structure to save some capacity and money. Let's move to the next slide, please. Okay. Now we're going to get into how does this work. Okay. How does this framework run? In a normal Java, what happens is that during the build, we do the packaging with Maven, Gradle, whatever, and then at runtime, the server has to unpackage that application and expose those servlets, those APIs, those web services to the outside world, and that is what is the unpackage. This is why the server takes a little bit longer when it is starting. Let's move to the next slide. In the Quarkus way, when we are building functions, all that pre-build, all that preparation happens during the build time. So you have two ways of building applications with Quarkus. One is like on a debug mode, like in the old-time debug compilers, where you have the code changing constantly on a runtime, and you are testing constantly. Now, when you are ready to do a release, like in the old times, when you do the release, that creates a package that is then ready to run in a production environment. That release, that is still a jar, will have everything ready to be deployed and run. And the runtime doesn't have to unpackage, it's just take it and run. And it runs always the same time, the same way. Let's go to one more. So when we do an ahead of time build, we do the compile, the provision, the assemble, and then JDK hotspot or AOD native compilation, and then the executable image. This second path is these last two parts is what I was referring to. You can have things that are running constantly and refreshing your server, and things that are running every now and then, and you decide I need to create an executable image. Let's move to the next slide. All right, what is these extensions and what are examples of those? Again, there are hundreds of them. When we are taking the code, we go quarkus.io, I want to start coding. You will see hundreds of things that you can add to your application. We do, in our case, we do a lot of development with Camel, with Apache Camel. And Apache Camel has functions and a good part of, like I would say 90% of what we can do with Apache Camel on a Spring Boot container, we can do on a Quarkus core. Now, we don't have to, there are two ways of getting there. One is changing our code to adapt it to GraalVM and make it super optimized. Back to your question, I think it was George. You have to code specifically for that GraalVM. Your code has to be like that. There are others that take Spring Boot code, precompile it to run as Quarkus. Like you take your injections and they are precompiled into an assemble that then gets compiled into an executable unit. Those that are not super optimized, they can still run as Quarkus, but they are not as optimal as something that has been built from the ground up. There are hundreds of examples. If you search in GitHub, you're gonna find hundreds of examples of both. I'm doing the conversion. In Red Hat, there is a toolkit that does a migration and analyze your code, your repository. So you put your repo for a Spring or a Spring Boot app, and it goes into your repo and tells you what do you have to change to make it run as a Quarkus inside of Quarkus. I think it's pretty useful, pretty great, and it works very good.
I have an example on the extensions as well with a organization that once they moved to Quarkus, their productivity started to outpace their CI/CD process, so they needed to deploy faster. So what they realized, though, was it wasn't really their deployment is where the problem was. The problem was orchestrating all the efforts and handling after the deployment activities were done. So they were faced with some challenges, such as environments got more complicated with more services, debugging distributed services was challenging, different tool sets were needed, no isolated way to develop or share work, and then collaboration between front and back end teams were lacking. So how they solved that is they solved this through Quarkus extensions. So they were using some extensions for the for Quarkus GitLab, and I'll go through a couple of the extensions that they used to help solve this problem. But the outcome ended up being, they already had moved to Quarkus. They now use these extensions. It saved them time, reduced their efforts, increased visibility, fostered collaboration, and minimized complexity. And the big extensions that, if you're looking at Quarkus and you use GitLab, you might want to look at is the Quarkus Kubernetes extension, Quarkus Kubernetes configuration extension, as well as the Quarkus logging sentry for GitLab, Quarkus small RAI health, Quarkus small RAI open API, and Quarkus small RAI open tracking. These are some extensions that they used in order to help solve this problem. So here's another real world way to take something that's improving your life, but then using the extensions to be able to integrate that with other things that you're already using. Back to you.
Yeah, there is a. I think I have one more slide for the extensions. Let's go one more, please. So how do we code for this? I'm very partial to VS Code. I think it's super light and I like it. And Eclipse they have a solution for everything. IntelliJ works great. We are doing now a project with one of our clients to enable this to be done from their own cluster. One of the issues when you're developing these things is that usually a service doesn't work by itself. So it leverages other services. And when you want to run something and you don't want to mock absolutely everything, but this has support for Mockito, of course. If you want to run with mocks, you can run with mocks. But when you are developing and you want to test against other microservices that are part of your change, and maybe you're changing 3 different functions and you don't want to overload your local environment, for this customer, what we are doing is creating their own sandbox where they have She as their developer tool. They work, everything is on the cluster. And now the code doesn't leave the cluster. Nothing is replicated anywhere. They are also super strict about security. So they don't want anybody installing anything, nobody pulling code into remote desktops that somebody can pull, somebody can take. For them, it's a great solution. And that's what we are building. The CI/CD, of course, runs in the cluster. We have Tekton in that case, like Todd was indicating earlier. It is a great solution. Using She in combination with Quarkus, it is a good option. Both lightweight. If you're using She, or if you have used or tried to use She for big applications, you have probably have a bad taste in your mouth, or at least I used to have. I don't know if now is a lot better. I'm very partial to VS Code, so that is my tool of choice. But in several customers, we have been talking with them about She, and for this small type of development, it makes a lot of sense. Let's move to the next slide, please. One more. So, can you add your own dependencies? Yes, you can. You can add your dependency with a migration toolkit that is then going to be pre-assembled, or you can write your own extension. The same as MongoDB is writing an extension for Quarkus, you can write your own extensions with functions, with things that you can use in all your functions. So it is a way to extend the language, and it is available for everybody. And it's normal Java, not big difference. Let's move one more.
All right, so just to kind of reiterate, I have a quick demo. It's from Burr Sutter. He's the director of development experience at Red Hat. If you've never seen Burr live, I highly recommend it. He typically is one of the keynote speakers at Red Hat Summit. So let me see if I can cue this up here. This is a demo that is on demonstrating what Jose was talking about in the sense of the footprint, and he's comparing Knative and OpenShift serverless on Node.js, Quarkus, and Spring Boot. So let me see here if I can.
So as I was saying, I'm a big fan of reusing. I was thinking about preparing a demo, but it will not be as good as Burr. So let's see his.
Can everybody hear that?
No. No audio.
Okay, hold on here. Let's see, it might be going. Let's take a look. Hold on. Okay, hold on. Try this again.
But all of these, of course, are out there as kubectl, get CRDs, grep, Knative. So if I look at the different types of extra custom resource definitions that Knative has added to my cluster, then that's how this magic happens. If I come look at my console, so my OpenShift console will have, let's see, these installed operators. You can see I got a bunch of them here, like Kafka. I have Elasticsearch. Basically, I have Istio, Elasticsearch, Jaeger, Kiali, known as the service mesh, but the serverless one, the Knative one, is the one we're talking about right now. And that gives me, of course, the pods in my Knative serving. But it basically means I can now deploy Knative serving components to the system, and they just have this dynamic auto-scaling capability. So let's go ahead and do this. Let's actually come back over here to kubectl get kservice. There we go. And maybe to kind of prove my point, let's actually just kind of highlight this right here. Okay, and then I'll say curl, and then we'll just curl at one time, and you'll see it come to life. There it comes to life, and you notice my curl is waiting. It's waiting for that Quarkus application to come up, and then of course it'll dynamically scale up that pod, give it, once the app server comes to life, it'll respond to my request, my curl request, and you can see the example there responds with aloha. Let me try my Node.js one. Let's curl it, and there's the Node.js coming to life at this point. Okay, and actually notice it's terminating also. My Quarkus one is terminating, and that is because I am no longer touching it. So we have this set to aggressively downscale. So the beauty of Kubernetes, or sorry, the beauty of Knative is that as long as you continue to interact with the pod, interact with that application, it'll keep it alive. And as soon as you stop interacting with it, it'll downscale it automatically. So I'm going to run this little script I have down here is basically a curl in a script, a while loop. So it'll actually keep it alive. So let's actually bring the Node.js one back to life. And then let's kind of look back over here at our Spring Boot one. Let's see it, and let's kind of bring it up. Here we go. And I'm going to say curl that one and get it up to life. And you'll notice I'm using all my command line here. And I could easily kind of done this from the graphical console also. With the developer console, I could have come here. And you kind of see these guys coming to life. There's Spring Boot coming to life right there. But if I wanted to add a new component, I could say add. Maybe I want a container image. And I'll just use one I know I've used before, OpenShift, hello OpenShift, as an example. Okay, and it'll say, let's add it to this app. Let's do unassigned, and let's give it a name. We'll just call it 2 because I've done this before. And I'll say, make it a Knative service. So this automatically gives you the dynamic auto scaling out of the box. And it also gives me an exposed ingress, in this case, what we call a route in OpenShift. And if I hit OK there, you'll see it start coming to life as well. So there you can kind of see there's my running Node.js, my running Spring Boot, my running Quarkus applications. Let me come down here actually and make sure my curl is running for Spring Boot to keep it alive. because otherwise, again, if you're not touching it, Knative will auto scale it down. You can kind of tell Knative is involved with this too. See the 2x2? That's because the Knative sidecar has been added to that pod. And that's, so look for that 2x2. If you have a 1/1, you probably have deployed it as a normal image, a normal deployment, not a Knative service. Lots to be said about how Knative services work, but it's actually very straightforward. You can saw how I basically dynamically deployed it right from within the console. Like here's this one here. I can use the URL to bring it to life. In this case, the curl command again, if you will, or in this case, the browser, clicking on that exposed URL, brings it up. It says, hello, OpenShift. I come over here, you can see it's a nice blue, meaning it's up and running now. So the beauty of Knative is in the serverless world, things go up and down. The last thing I want to show you, let's double check that these things are up and running. Yeah, we have our Node.js interacting with, we have our Quarkus, we have our Spring Boot, and you can kind of see they're all running right here, and including the hello OpenShift, by the way, which I said just ran from the browser. But there's a Spring Boot one, there's the Node.js one, there's the Quarkus one. Let's also look at the OpenShift console with UNIFIES built into it, Grafana built into it for monitoring. We're going to basically look at our Grafana console. Last 5 minutes, you can kind of see we're in the Prometheus data source. It's under side by side. And right now, what I want to show you, if we can show you, there's a CPU quota and memory usage. And let's see the memory quota down here. So if we look at our Spring Boot application, it's currently using 120 megs of RAM. Right there, Quarkus application using 38 megs of RAM, and the Node.js application 45. My 45, Node.js using 45. So this should be interesting to you guys right away. Basically, our Quarkus Java-based application is smaller than the Node.js application, runs faster as well. Of course, it's compiled to a native binary there using the Grail VM technology. It's one of the powers of Quarkus. The same programming models you would have in Spring Boot, but Spring Boot, of course, is being 120 megs of RAM. So when you're building serverless-based applications, you definitely want to be thinking about the performance characteristics of it. Is it super small? Is it super fast? That's why in Quarkus, we call it SUPERSONIC, SUBATOMIC Java. But that's my quick demonstration of the side-by-side. I'll provide this link, the link in the notes below to the actual applications.
All right.
All right. So leave it there. Leave it there, please.
Sure.
Leave that there. So just one comment, because Bart speaks super fast. Just in case, one thing to note: like all applications were doing the same thing, and he was composing. The demo was composed of 2 different things: Knative as a way to auto scale from 0 to 1 container, or from 0 to whatever number of pods you need your containers to have, so you can serve your demand. And then he was comparing within that Knative, he was deploying a Spring Boot, a Quarkus, a Node.js application doing the exact same thing. So it was like an Apache server running a call to do a response with an HTTP of a message. It is a very basic application, but that very basic application in Spring Boot is consuming 120 megs of RAM, and takes, like, if you look at by any KPI, in any one of the indicators, is consuming a lot more. Like from memory to CPU, like you cannot see the CPU right now. It was in the chart above, but from memory to CPU, everything is more. The response time is more. The startup time is more. So again, it's not the solution for everything. It is not get rid of every Java that you have and transform into Quarkus and everything is going to be hunky-dory. The Java applications will have a place that are more skewed towards a Spring Boot, and some others we're going to have to be more skewed towards Quarkus. On Quarkus, if you go to the Grail VM and you have big garbage collection events, those are highly penalized. That JVM is not optimized for garbage collection. It's not designed to have a function that is running for a long period of time. If you have a function that needs to run on a longer period of time, use not the Grail VM, but Mike, can you go back to the slide deck, please?
Yep. On here.
And go back a couple of slides where we have the 3 different versions running.
Where are we?
Go back is, let me tell you the slide. 27.
27, okay, got it. Let me get there, sorry.
One more. That. So if you have something that runs super fast, quick transformation service that you can run, you can do with a camel transformation, do it with Quarkus plus native and in a native environment, and that will run super fast. It's something that doesn't take any time. You have complex calculation or things that need to run during a job that you need to run for 5 minutes and it's going to trigger garbage collection. I would do it on a Quarkus plus a JVM with a full JVM, so I can enjoy that garbage collection, that JVM feature. If I have something still bigger than that, where I need to have very complex business logic that does not fit into the Quarkus model, I would run it into a Spring Boot. As I said at the beginning, the whole purpose of this is to give you guys another tool for your tool belt, so you can recognize more things than just hammers, that just nails. So if we go back to the end of the presentation, Mike. Yeah, there. I think Todd wanted to present some use cases that we have done over the years. And again, this is super popular now. The speed of Quarkus is insane. A little bit. They up to half of this first year, up to 2021 June, they were coming with 2 releases per month of Quarkus. So a new release every 2 weeks. There is a lot of innovation going on in this environment, in this infrastructure, with new tools, with new libraries that are available for us. And as a result, it is a better tool. Every month is a better tool. It is still evolving. It is still very young. It's a very young platform. And in my opinion, it's huge hopes for it.
So just a couple notes. So if you currently own subscriptions to OpenShift, Quarkus is, you already own it. Also, if you have Red Hat runtimes, it's incorporated in that. So a lot of people don't know that. For instance, I have customers that had just EAP, Enterprise Application Platform, and that's also included in runtimes at the same cost. And so you will also pick up other supported Red Hat, for instance, like Quarkus. So I just want to throw that out there. Todd, did you have a couple other examples of use cases?
I threw my examples in midstream.
Okay.
We're going through. Yep.
Okay. Yeah, just, hopefully, from this webinar, you're taking away that you're getting improved app performance and cost. So you're going to reduce, memory consumption, startup times, reduce application size. So, and then as far as like the whole digital transformation, you can modernize and optimize existing apps. So that's where, going from that monolithic to a microservices is really advantageous. You need lightweight connectivity between services. And then hopefully you saw that you could, the whole serverless and taking advantage of, seldom but critical services that you would need. So that's what I had. Is there any other slides that we talk about the benefits of Red Hat and, the whole lifecycle management, the support behind that for the Quarkus version. Any questions there? I see some questions in the chat. Did we respond to those? Oops.
Yeah, when I did respond, just in case, is it clear, the response? I don't want to come across like does not do garbage collection. It does do garbage collection. It's just, it is not great at recovering big amount of memory, like you would have in a Spring Boot, where you could recover like 1 GB of RAM or 2 GB of RAM or 3 GB of RAM.
So if you have, you have a Java app, you have some questions about it, like would this work well with Quarkus, reach out to us and we can get on a call with you, get some team members, to walk through kind of your use case, and we can help point you in the right direction on that. We also do have resources to help augment your team so that your team can learn this and how to optimize what you're doing in OpenShift with Quarkus. So we're here to support you. Just reach out, let us know what your thoughts are and what you're trying to improve, and that's something we can help support you guys on. Appreciate your time.
Yeah, thanks everyone for taking time out of your day to join us. We will send the slide deck out, and our contact information will be in there as well. So we look forward to working with you. Thanks everyone.